In my last video, I introduced you to a game you can play which demonstrates how we transmit information on waves. A process known as shift keying in the digital age used to be known as modulation. In particular, we did both amplitude shift keying and phase shift keying. In fact, that latter one is exactly how Bluetooth works. But I posed you two questions. The first was, based on the properties of the original carrier wave that we were putting that information on, what is the data rate? Now we can see from our sheet that every single bit here corresponds to one oscillation of the carrier wave. That means there's one bit per oscillation. So essentially, the data rate, the number of bits per second, well, that's just the frequency. So that means that higher frequency waves can transmit more information. That's, for instance, why fiber optic broadband, which uses visible light, is a lot faster than 3G or 4G, which are in the microwave end of the spectrum at a lower frequency. In fact, we'd never actually do it such that there is only one oscillation per bit. For bandwidth reasons, it means that you kind of can't have any other channels. So we tend to have a few instead of just one per bit. The other question I asked you is, how can I, without changing the properties of that carrier wave, still increase that data rate? Did you have any ideas? I think the obvious one you might think of is, okay, we're doing things in binary. That means there's only two levels. There's a 0 or there's a 1. What if we had more levels? That could be more levels in amplitude or different starting phases that we could use. We could then have more than one bit per oscillation. Let's say, for instance, instead of just 0 and 1, we did 0, 1, 2, and 3. That's 4 different levels we're using, which is essentially 2 separate bits. Live long and prosper. That means our data rate is now 2 bits per oscillation. The other way you can up the data rate is combining the two different methods. We can change both phase and amplitude at the same time. They are completely independent properties of the carrier wave that we're modifying. So we can totally do this. In fact, Wi-Fi does both of these things. It uses more levels and it uses both amplitude and phase shift keying at once. Did you guess any of those two answers? If you did, let me know in the comments. Thanks for watching.